Okay, class, so we're going to do an actual example of Euler's method here with this differential equation. So dy dx equals x plus 2y. Our initial condition is going to be y of 0 equals 1. And we are going to approximate y of 1 using two steps. Okay, that's the same thing. They could have just said the step size is 1/2. Notice that the interval in this case is the interval from 0 to 1, because we're going from 0, x equals 0 to x equals 1, and number of steps is 2, so that delta x is 1 minus 0 over 2, which is 1/2. Okay? Alright, so let me put the two formulas down. N plus 1 equals xn plus delta x. And then y sub n plus 1 is yn plus f of xn yn delta x. Okay, so here's how we're going to do this. So we're going to build these two formulas into a table. Okay, and this is very frequently, this is how you'll see, if you ever watch anybody do Euler's method with anything, this is sort of what they'll do. So let's see, what do we need in terms of our headings up here? We're going to know what step we're on. We're going to know the x value. And we're going to know the y value. We're going to calculate the slope, which is f of xn yn. And we're going to need to know the delta x. And now notice we're doing two steps. So n is going to be 0, 1, and 2. So that would represent my, I can't see I've been holding all this from you, okay? So let me just go through this again. So the column headings would be n, xn, yn, f of xn, yn, and delta x. Okay? And I know there's going to be two steps, so I went ahead and just put two steps here. And I know my x0, y0 because it was given in the problem. It's right here. So x0 is 0, y0 is 1. Okay? So I take those two things and I plug it into the f of xy. So x is 0, that means 0, and y is 1, so that's 0 plus 2 times 1, that's 2. Okay? So down here, got a 2 there. And delta x is always the same thing, it's 1/2. Okay, now let's go to the xn column because that's the easiest one. Okay? So we're going from 0 to 1, our step size is 1/2, so we know that x1 is going to be 1/2 and x2 is going to be 1. Okay? We can figure that out without doing any other calculations. It's pretty much the easiest thing to do. Alright, here's the cool part, okay? So if you make your table this way, then all you kind of need to think about is, I'm going to just put it up here, a plus there and a times there. Okay? So if I'm looking at my formula, x1 is going to be y0 plus f of x0, y0 times delta x. So if I'm looking here, it's this plus this times this, and of course you need to do order of operations. So 1 plus 2 times 1/2 is going to be 2. Okay? Same thing. So we plug 1/2, 2 into this. So that means 1/2 plus 2 times 2, that's 4.5. I'm going to write it as a improper fraction, so that's 9/2. Delta x is always 1/2, so I don't have to think about that part. And getting the next y value, 2 plus 9/2 times 1/2, that's, let's see, that's 2 plus 9/4, that's 4/4 plus 9/4, that's 13 over 4, and that's the answer. Okay, that's the approximation. So y of 1 is approximately equal to 13/4. Okay? So I'm going to show you another method. So this is if you can remember everything, put it in the table, know what to do with the table. Okay? And you know, just thinking about the table, if you make your table like this, if you're practicing it this way, you don't really need to think about what the formulas say. You just know that you're adding and multiplying, and then all that together gives you the next value.